Cross-section is a two-dimensional shape that is created by slicing a three-dimensional figure by a plane. Now, if you've never heard the term plane in a mathematical context, we're not talking about what's flying through the sky. Essentially, imagine just a piece of paper. Okay, that's a plane. So try to picture in your head, this first question here says, if a sphere is sliced by a plane, what cross-section is formed? So picture a basketball, soccer ball, volleyball, baseball, anything of that nature. Okay, those are all spheres of various sizes. If I take a plane and slice right through the middle of whatever ball we're talking about, and I open it up for you to see it, what shape are you going to be looking at? A circle. You're going to be looking at two circles, right? You've got one on each side. So that is the cross-section that is formed. And I'm writing cross-section because I'm saying cross-section. Circle is the cross-section that's formed, okay? Now, let me show you on this applet here. It's on Haiku. I have it on our day 49 page. And then, there we go. Okay, so we're on Unit 5, 2D and 3D figures. Day 49 is where we're at. If you click here on the cross sections of 3D shapes, you'll see that you've got a bunch of different options here. So we're talking about a sphere, so we click on the sphere, and it shows us a sphere, and here's our plane. Okay, it kind of looks like a piece of paper there. You can move where that is in the sphere. You can move it up and down, so you can make it bigger and smaller. Okay, you can rotate it. Right now it's horizontal. You can rotate it to vertical. You can put it somewhere in between. You can also rotate it around this way. Okay, it just kind of depends on what the question's asking you. So once you do that, you can click right here and it says view from the section, and it's going to turn it around and it's going to show you the shape. That is the cross section right there. Okay, you can reset it up here in the corner. You click the little reset button. And if you want to, let's move it back kind of towards the bottom here. Let's look at it, see if anything changes. Okay, it's a smaller circle, but it's still a circle, right? Okay, so that one's pretty easy. Let's talk about a cone. If we take a cone, so imagine kind of like a traffic cone, and it's sliced parallel to its base. So we're just assuming that it's sitting on the ground, and we're going to slice it parallel to its base, and we're going to hold it up. What shape are we going to be looking at? Another circle. Good. Okay. There are cones on here as well. So right now, it is parallel to its base. So yes, that does produce a circle. Now, what if we change that and we say instead of being parallel to the base, we're perpendicular to the base? How is that going to change the shape? Is it still going to be a circle? No? Okay, what do we think it's going to be? Triangle. Okay, so if we make this completely vertical and we look at it, yes, indeed we have a triangle. Now, is that the only option there? Do you think if I move that, it would give the same shape? Okay, so I still want it vertical, okay, but there was nothing in my instructions that said that it had to go through the tip of the cone. So what if, I think, but yeah, if I move, nope, not the height. Nope, not that one. Here we go. If I move it using the little arrows over here, okay, is that still a triangle? It's a rounded triangle. We don't really have a geometric name for that shape. I'm going to call it a rounded triangle. Again, nothing mathematical about that term, but we don't have a good name for that. So it just depends on the specifics that they give you in the problem, or whether they give you specifics or not. Okay, so be careful on some of these questions that they ask you. Some of them say check all of the following that apply. So don't just go with the very first thing that you think of or the very first thing that you see. Play around with it. Try to think, are there other options to this scenario? Okay. How about if we're talking about a square prism? Okay, a square prism. So we've got a square on the base here, and it's a prism, so it's taller. Okay. So pretend those side lengths are the same down here. I actually did a fairly decent job. Okay. If we slice that parallel to its base, we go right here. What shape are we going to end up with? Square, because that's the base. Absolutely. Is it still a square if we go perpendicular? No. Okay, what is it? A rectangle. Very good. Okay, so cross sections, not super hard. I do want to show you one thing. I don't have a question about this, but let's look at, I don't know, let's look at a pyramid for a second. Okay, what if we go like halfway in between horizontal and vertical? Okay, I'm not parallel, I'm not perpendicular, I'm kind of in between. And what if I kind of turn it around right here? Kind of end up with funky, it's not a rectangle, it's not a square, it's just a quadrilateral, it's just a four-sided figure there. And I can still move it from here. Now, there are ways I can get back to a triangle, even though it's not completely parallel or anything like that. So there are a bunch of different options. Let's look at a prism over here. What a triangular prism. Ended up with a trapezoid right there. Okay, or I can turn it right here and I end up with a 1, 2, 3, 4, 5-sided. I end up with a pentagon of sorts here. So that's what I'm talking about with kind of play around with it, move it around, see how many different possibilities you can make, because it really does depend on where that cross section is located. It doesn't have to be completely horizontal. It doesn't have to be completely vertical. It can be somewhere in between and kind of cockeyed, okay? But you really just kind of have to play around with it to come up with the different scenarios. I don't have a magic formula to give you for that. You have to be able to see it.